All right. Well, welcome everyone to today's quarter conversation. What's music good for? A cognitive scientist perspective with Dr. Robert Slevc at the University of Maryland. I'm Bonnie McClellan, a member of the Quarter Conversations organizing group and a longtime member of Explorations on Aging, College Park. So what exactly is Quarter Conversations for those of you who are new? Quarter Conversations is an online series that highlights the people, culture, and heritage that help make Route 1 corridor the integrated, friendly, and stimulating area that it is. The series is a collaboration of villages along Route 1, including Hyattsville Aging in Place, Helping Hands University Park, Neighbors Helping Neighbors College Park, and Explorations on Aging College Park. The series began in 2020 when it became impossible for us to do in-person programs. And we thought, we can do this online. And so we still are, and happy to do so. Today's event, a program highlighting music and the brain, is our 10th quarter conversation this year alone. To begin, we have to ask, why is this program important? Why would we even want to have this program? Many of us have heard of or know persons whose ability to express themselves, whose memory for names and words and events has been compromised as a part of aging or traumatic brain event. Yet amazingly, they are able to sing full songs, completely remembering all the words and the tunes, and it is amazing. And then, of course, you know about music therapy. Music therapy has been around for a long time. You're invited today to join with Dr. Slevc to learn some of what cognitive scientists are uncovering here at the University of Maryland and elsewhere about how music can help our brains. Dr. Slevc is Associate Professor and Associate Chair in the University of Maryland Department of Psychology, as well as a part of the university's program in Neuroscience and Cognitive Sciences and the Maryland Language Science Center. His research focuses on processing of language and of music in both normal and brain-damaged populations. So welcome, Dr. Slevc. We are so pleased to have you.
Well, thank you very much. What a nice introduction. I wish I was talking more about aphasia stuff, but that's okay. We'll talk about it as we can. Let's see. Let me get as I understand it, the way you do these is you say, can everybody see my slides? And then you sort of peer around awkwardly for a little bit.
Yeah.
Good. That worked. Or did it? There we go. Just first a little caveat, I suppose. Like when I was first talking to Bonnie about this, I thought like, oh, I think at her suggestion, I was like, this is great because I can just basically play music for people. And so I can say a few things, and then if people are starting to get bored, I'll just play some music and everybody will be happy again. But I realized that, it goes on YouTube, and YouTube has these somewhat draconian copyright infringement policies. And so I was trying to decide what to do. Do I figure out exactly what size of clips you can get away with? Do I try to sing everything myself? I don't want to subject you to that. So, but fortunately, I don't have to provide the music because you have it in your heads. So, for example, you all, I think, probably know the Star Spangled Banner. And so I could ask you a question. I could say, hey, here's the task I'm going to give you. I'd like you to tell me if the pitch of, in the first line, "Oh, say can you see by the dawn's early light," is the pitch of can higher or lower than C? I'm not sure why I'm waiting for a response because you're all muted, but think about that. And I can ask you also, is can higher or lower than dawn's? Right, and if you can do this, what is usually the case, it's like pretty consistent, is that it takes longer to do this the further apart the pitches are that I ask you about. It also takes longer the further the pitch is from the beginning of like a phrase boundary. And that's kind of interesting because what that suggests is that even though your mental representation of the music doesn't have to unfold over time, like the song, any part of it, like it's not like you have to know it in order. But it seems like when you make these kinds of decisions, when you think about it, it unfolds over time in a way that's sort of analogous to hearing it. And this is auditory mental imagery, of course. And there's like a lot of pretty interesting work on what exactly that is. But the nice point for our purposes is that I'm just going to tell you about music, and hopefully you can imagine it. And if not, you can also just look it up on YouTube or something. So with that tool in mind, I want to talk a little bit about kind of this big question of what music is good for. And before I do that, I should actually just say, like, what's music? Because it's not entirely obvious, right? Like, I think maybe we could all agree that here's, you have to imagine this, but here's Hilary Hahn playing like a lovely violin concerto. I think we can agree that that's probably music. Here is Ben Stein in Ferris Bueller's Day Off as a sort of very sort of stereotypically monotone economics teacher. And I think we could probably agree that that isn't music generally. But of course, there's a lot of stuff in between, right? I mean, you have Bob Dylan, who we think of as a musician, but won the Nobel Prize for Literature in 2016. You have NACS doing, sort of hip hop and rap, which doesn't seem to me all that different from Amanda Gorman reading poetry, which doesn't seem all that different in some ways from like Allen Ginsberg reading Hal, which really is not that different in some ways from like coordinated chanting at a protest. And so like, where do you, like, which one of these things is and isn't music, right? And it gets tricky also because even like historically, right? If I was talking to you 700 years ago, well, first you'd think like, what is all of this magic so that I'm talking to you on the screen? But it's also the case that creating music with harmonic progressions was really quite rare, half a century ago. And so like really only a couple of locations in Western Europe were doing sort of like harmonic progressions of the type that you get in, almost, well, at least the first set of things over here. And it gets even harder when you move out of our own Western musical tradition, right? So in Bulgarian diaphonic folk music, the choirs tend to sing in these like parallel parallel seconds, which is by Western standards really quite dissonant and kind of strange. Balinese gamelan, some of you may be familiar with, is pretty interesting because, the instruments, the flutes tend to be tuned kind of totally independently of the rest of the ensemble. And Balinese singers change mode depending on things like the character of the scene, which is independent of what the instruments do with which they're performing. So it's, from a Western standpoint, it's really weird. And it's not just about polyphony, right? Multiple things at the same time. It's also about tuning tolerance. So like in Central Africa's version of the pentatonic scale, for example, a scalar step can sometimes be off by as much as a half step by kind of Western standards and still be considered in tune, right? Which it would not be here. Or, you can take things that are sort of intentionally pushing the envelope, I guess. Like, so for example, this is Alvin Lucier recording I Am Sitting in a Room, which if you're not familiar with is a really interesting piece where what he does is he sits in a room and he records himself narrating a text about sitting in the room, sort of ironically, I guess. And then he plays the tape recording back into the room and re-records it, and then plays that recording back in the room and re-records it, and does this on and on. And because of the room, basically the room size and geometry causes certain frequencies of the recording to be emphasized and others to be attenuated, and eventually the whole thing becomes unintelligible, and it just sort of sounds like the characteristic resonant frequencies of the room, which is pretty cool. It might not be what you want to sit around and listen to all the time, but it's a really interesting demonstration. Is that music? I don't know. Like, in a way, the question of like, is music good for your brain, for example, right, is almost always talking about Hilary Hahn type music, right? Maybe Bob Dylan, but that's usually what people are investigating. And so I just kind of want to throw this out as a little bit of a caveat at the beginning that like, what we're talking about in the sort of scientific field so far is a really, really limited kind of window of what we mean by, or what music probably is, to the extent that we even know, which I don't think we do. But caveat aside, what is at least something sort of like Western tonal music good for, right? And one of the most vexing questions about music is like, why does it exist, right? I mean, most things that we put the sort of effort and energy into, that we put into, have like obvious evolutionary benefits, right? We work hard to get money for food and shelter and things like that. But like, why do you spend your good money on music? Sort of unclear. And so you might say, well, like if we're talking about evolutionary utility, you might think about sexual selection, right? That's a sort of classic evolutionary sort of argument. And there's been a lot of writings on this over the years. But what there hasn't been is any actual evidence that this is true. And there's some pretty serious problems here, right? The biggest one is that there's not gender differences, and there's no like obvious effects of sexual maturity on music preference or music making. There's been like, people keep trying. There was a study a few years ago looking at how women's musical preferences change around ovulation. The answer to which was they don't really. So that doesn't like buy you much in terms of this particular kind of theory. So maybe, I think you could argue that like people who are really good at things can be attractive, and that's fine, but that doesn't seem to be something that music evolved for, in my opinion. Something maybe a little more clear is something like social bonding. So you might imagine, that there's different versions of this, but one might be that a sort of like social bonding, because like when you do things with each other, it sort of brings you together. Before the talk started, we were chatting a little bit about some work with infants suggesting that they tend to show some preferential behavior towards people who move in synchrony with them, which might be kind of a precursor to that, which is kind of interesting. They'll also be more pro-social to people they have sung with, which is kind of cool. So maybe there's sort of a social bonding component there. A related one is what people sometimes call coalition signaling, which is kind of this like what you see with marching bands and like military parades, and like this is the haka dance for the New Zealand rugby team, which you could also Google if you want. It's pretty wild. And music is often performed in these kinds of situations, like during war and in sort of like cross group things. And you can sort of think of it as signaling group identity and signaling also a bunch of cohesion to another group, right? Kind of a like, we are all in this together and we can kick your butt kind of move. And I think there's something to that. But that might be important, but it's weird then that you would listen to music alone. Like, why would anybody have a hi-fi system in their house to listen to music by themselves, right? And why would anybody create music that doesn't follow popular taste if it's about bringing everyone together? And why would you listen through headphones, right? I mean, that's, to the extent that any of this stuff is social, like listening to things through headphones is a bit weird in that kind of component. And so there's another theory out there, which I actually think, it's going to be some combination of things. And this is a theory that people often don't, it's phrased in a sort of a snarky way, but it's basically the idea is that music is something like auditory cheesecake. There we go. That's the best picture of auditory cheesecake I could find.
Looks good.
Give talks before the internet. And the idea here is that, music is like basically a thing that we have developed to sort of tickle our brains by acting on reward systems that we have for other reasons that are already sensitive to repetition and novelty and things like that, right? That music it's in the same way that cheesecake has really not a lot of good nutritional value, but it has a lot of things that make us like food that typically would have been good for us to eat, evolutionarily speaking, to kind of, store up energy and all that kind of thing. And I think that's probably true to some extent. But it's also the case that people seem to hold a pretty strong belief that music isn't just some kind of spandrel or some kind of byproduct of other abilities. And so instead, like music, instead of just being a byproduct, you might ask, well, maybe music, or people have asked, maybe music like actually contributes to other things, right? Maybe it's actually the important thing in some way. And so perhaps you've heard of versions of this, like the Mozart effect. The Mozart effect, as you probably have heard, is this thing where, like if you listen to Mozart, you get smarter. That's the idea works something like this. You have like somebody who's maybe not at the top of their game. You give them like a nice batch of Mozart, and then they're like totally killing it, right? And it's it's an idea that has gotten a lot of traction in the sort of popular science world. You can go out and you can buy all sorts of different albums to play to your babies to make them smarter. Including prenatally, by the way. There's a thing called a pregaphone, which maybe you've heard of, which is basically like a big old, it kind of looks like it reminds me of the old Victrola, like amplifier things on the records that you just kind of put on your belly, and then you play music that presumably to the fetus sounds like some sort of like terrifying low pass filtered Mozart, as if you were listening to like a symphony playing underwater. But, it has some of that information, kids probably learned something from that. There's actually good reason to think that kids pick up some things that they hear prenatally. And of course, it doesn't have to be just for kids. You can do this as adults too. You can go out and get all sorts of albums that will make you smarter. I should note, by the way, that in terms of the kids stuff, people got so excited about this that the governors of Tennessee and Georgia in the late 90s or around 2000, I think, started these programs that sent a Mozart CD to every newborn in the state, which you can kind of see as like, the governor of Tennessee and Georgia being like, hey, like, we're not really killing it here on the sort of rankings state-wise, but what if we just like get a couple baby geniuses in right early, right? It's going to be amazing. Florida's legislature passed a law requiring classical music to be played in state-funded childcare programs. Hundreds of hospitals were given free CDs of classical music by the National Academy of Recording Arts and Sciences Foundation. So people were like, this is great, like Mozart for everyone. It's great. Like, we know it works. And like, how do we know it works exactly? Right? That's a good question. So what's the study? The study that this is all based on is from a 93 paper by Rauscher et al. And the paper itself is pretty reasonable, but I think maybe the conclusions are a little overblown. So what they do, they were interested in, basically effects of different sorts of things on cognitive processes. And so they had, in this particular study, they had 3 conditions. What happened is people came in the lab and they had this little subterfuge where they said, oh, because they're psychologists, it's like everybody wants to trick you a little bit at the beginning. And they said, our experimenter's running a little bit late. I'm really sorry. But just hang out here for a couple minutes and we'll get everything set up for you. And so for one group of people, they hung out in a room where there was Mozart playing. In particular, I believe it was Mozart's Sonata for 2 pianos in D major, which is nice. For another group of people, it was a relaxation tape, like a sort of spoken word meditative thing that was designed to lower blood pressure. So supposedly relaxing. I don't know how relaxing college students find that. And for another group, there was nothing. It was just an empty, quiet room. So they sat there for 10 minutes. And then they said, okay, great, here's the experiment. And the key part of this, it was a bunch of different tasks, but the key part is a task of sort of spatial ability. And this is a standardized test, part of a type of IQ battery. And the way it works is you look at this top part and you say, okay, imagine you have a piece of paper and you fold it in half like this, and then you fold it in half like that, and then you fold it in half like this, and then you chop off this corner with a pair of scissors. Right? Now, if I unfold this paper, what of these am I going to get? And now is where I try to make you guess, but you're all muted, and so you can all just pretend you got it, I guess. If somebody wants to chat the answer, you can, if you feel brave. I'm actually trying to remember what the answer is. I think it's B, but I could be wrong. Pretty sure it's B. Probably shouldn't have said that. Anyway, so fine. So people did this. It's a bunch of problems like this. And then they just look at how that differs across groups. And sure enough, the people who had listened to Mozart for 10 minutes did significantly better, like a decent amount better, not like, way, way better, but like they did better at this task. So that's pretty cool. In a bunch of follow-up studies by this group and others, it turns out it doesn't have to be Mozart, right? Like it could be lots of different things. If, it could be classical music in general. It actually works best for whatever kind of music you like best. So there's sort of a titrate to the individual thing. So if you happen to like Schubert will probably work best for you. If you happen to be a big Metallica fan, Metallica will probably work better for you. If you are obsessed with yo-yoing, yo-yoing is probably a good thing to do, right? It seems like the key here is that these are really effects of arousal and mood, right? You spend 10 minutes doing something you like, you perform better after that. So the idea is, sure, what it really is less like it turns sort of dumb kids into smart kids, but it turns like grumpy kids into happy kids, and then they are smarter. And that's true for adults too. So that's the Mozart effect. That's it. It also lasts 10 or 15 minutes, after which people tend to hit baseline. There you go, right? Being in a good mood is good. Now, it's been highly oversold, but like for our purposes, it's kind of a funny, argument to make, I think. Like, if you're really talking about music and that's sort of big benefits on brain and cognition and stuff, like, are you really talking about listening to music? Maybe I'd be talking about like making music, right? Like the sort of skills and processes that are involved in learning to play or sing or music theory or whatever, right? What about music training, right? Might that actually be this this kind of process. And so, for example, think about the manual dexterity required for learning to play the violin, right? It's pretty complicated. It's a fretless instrument. You got to know exactly where to put stuff. People could get really fast. I'm not going to show this because, I'm not going to tempt the copyright fates, and it's not that interesting anyway, but what this would be is a video of a competition it's actually a German game show where they try to see who can play the Flight of the Bumblebee the fastest without making any mistakes. And whether or not you think that's the most sort of artistic rendition of Flight of the Bumblebee, I'm not sure I do, but it's technically amazing. I mean, the like speed of left-handed movements on some of these players is like pretty wild. And you might think like, well, how do you do that? Like, are there any consequence to that besides just being like really, really good at the violin? Another sort of famous study I'll mention is an Albert et al. 1995 study where they decided to ask that question, and they used an MEG, which is magnetoencephalography. And this is a non-invasive brain imaging procedure where we have one of these at Maryland, actually. They're not super common. You've probably heard more about MRI and fMRI, but MEG measures electrical potentials generated by populations of neurons in the cortex. And so what happens is you sit in this device, and this has basically a very, very sensitive magnetic field sensor that can sense the magnetic fields that your brain is producing across the scalp. And it's cool because it can tell you things very, very precisely in time in a way that MRI and fMRI cannot. Now, what they did is they said, well, let's ask about what it's like to be one of these amazing violinists who can do these amazing things. And so they got some professional violinists to come in. They said, please come in, we really need your expertise. And what we're going to do is we're going to set you in this really, really expensive machine. And we're going to squeeze, and then we're going to rely on the fact that we know that we know a lot about the neural organization for sort of sensory and motor processes. And in particular, they're organized in a topographic way. And by what I mean by that is that adjacent parts of the body are represented in adjacent parts of the brain. Right? It doesn't have to be that way, but that's how it happens to work out. So, the part of your brain that cares about tongue perception is next to the bit that cares about jaw perception and so forth. And for our purposes, what matters is around here where you have basically a little section of cortex that seems to independently and in order represent thumb through pinky on each hand. So on the right side, it represents your left hand, left side, it represents your right hand. Do that. And so what they did was they said, well, okay, we can ask about this sort of cortical area by basically plopping these professional violinists in here and then squeezing their thumbs and squeezing their pinkies and seeing how far apart they are. And so that's it. That's the study. You squeeze your thumb 1,000 times, you squeeze your pinky 1,000 times, so you get a nice, reliable estimate for a bunch of professional violinists and a bunch of controls who are matched in various ways. And I apologize, this is a little hard to see. But here, D1 represents the thumb, the bit of the brain that is responding to thumb squeezes, and D5 represents the bit of the brain that's responding to pinky squeezes, and yellow are the control participants as they sort of occupy that much cortex, and black going all the way out to here are the violinists, right? So there's a pretty notably larger chunk of cortex representing left hand for professional violinists than for non-professional violinists. Which raises all sorts of interesting questions, actually, like, are they worse at something else? Like, where did that cortex come from? But, that's cool, right? It's not just violinists. And when I say, where does that come from? One answer is that it looks like you might actually just have more neurons. So it's not just that it takes kind of more of the existing neurons, but here's some, this is an old paper, but just one that I think illustrates this pretty well. This is MRI now, but this is structural MRI, magnetic resonance imaging, which is basically measuring the concentration of gray matter, loosely speaking, in different parts of the brain, contrasted from expert pianists, amateur pianists, and then non-piano players. And these are areas where basically there's a consistent increase in gray matter. That is, expert pianists have denser neurons in, these again are the motor and somatosensory areas, similar to what we saw before, representing hands and so forth. And also down here in some auditory cortex, right? So some bilateral auditory processing. And so, having more neurons would seem good, right? And on one hand, that's pretty cool. And on the other hand, it's like kind of obvious, right? Like, where did you think violinist fingers representations were going to be? Like, of course, they're like in the brain where we represent fingers and hands and stuff. But like, it's interesting because what it implies, and again, this is, cross-sectional, so we don't know for sure, but what it implies is that learning this skill has like changed not just your how you are using these things, but the actual kind of structural makeup of parts of your brain, right? And that seems pretty interesting. That kind of neuroplasticity is something that people get really, really interested in. There's work on white matter connectivity too, but I'm not going to get into that right now because it's sort of confusing, at least for me. But what this raises, right? So if you say, okay, well, we don't, again, it's cross-sectional, it's correlation, we don't know for sure. But if it's the case that these kinds of experiences can really lead to these sort of structural changes, as there are consequences to that might go beyond music itself, right? Like maybe having these auditory areas and these motor areas has some consequence beyond just playing the piano. You don't have to look around too far on the internet to get a sense that people think that might be true, right? Music makes you smarter. And I think there's like kind of a couple things that are worth pointing out here. One is that, people talk about this in a couple different ways. So you could talk about transfer, where I could say, well, if I learn piano and I get better at piano, that's good, right? But that's not transfer. Now, if I learn piano, but it turns out I'm also better at picking up the violin, that's a kind of transfer effect, right? There's some shared skills, but a lot of different skills too. That might be kind of near transfer. And then you could say things like, well, if I learn piano, am I better at math, right? Or like spatial reasoning or something like that. And that's what people like to call far transfer. That's sort of the like holy grail of this sort of type of research, right? Can I just actually get people to get better at lots and lots of skills by virtue of this one kind of experience, which compared to other kinds of things people have looked at in this regard is great because people like music in a way that, I don't know if anybody ever tried any of these brain training programs like Lumosity or anything like that, but like nobody likes those, right? Like, I mean, maybe some people kind of like them. They try to make them a little bit like games, but like, if you really want something that's going to improve cognitive neural processes, right? It'd be nice if it was something you enjoyed doing that had some reward of its own. And in fact, there is evidence that musical experience is associated with a lot of different kinds of cognitive abilities. So there's some old but still very highly cited work, not that old, suggesting that musicians tend to perform better on intelligence tests than non-musicians. They tend to show better verbal spatial short-term memory abilities, better visual spatial abilities, a lot like the kinds of things that we were talking about before with the Mozart effect. You get these sort of main effective musical experience on those. Cognitive control and sort of like impulse control type processes, executive function, which is something like that, and other stuff like that. And so that's pretty cool. On the other hand, it's worth noting that musicians are not always like known for their kind of impulse control as a species, if you will, or necessarily their intelligence. This thing on the left over here, I don't know if anybody follows this kind of thing, but there's this rapper B.O.B. who got in a Twitter war last year with Neil deGrasse Tyson because he was insisting that the Earth was flat. And I feel like, I don't know what the stupidest part of this is, thinking that the Earth is flat or like deciding as a rapper that what you ought to do is argue astrophysics with Neil deGrasse Tyson. But I don't think you would call that, the most intelligent behavior. And, impulse control is Pete Townsend smashing his guitar. There's Animal from the Muppets, who I think is a clear case, obviously. Like, what's the story here? I mean, it does seem like there's good evidence that instrumental experience, especially, which is what people have mostly, back to my first point, what people have mostly studied is instrumental training and how that might impact other kinds of abilities. But it seems like there is good evidence for this, both in terms of better cognitive performance in adults and teens, but also some degree of like protective benefit, for example. So it seems like musicians in general tend to have a slight benefit in terms of Alzheimer's, in the sense that if they get it, they preserve sort of a little bit better functioning a little bit longer. That's true for bilingualism too, by the way. And so there's this kind of idea out there. And Bonnie mentioned this whole other interesting line of work, which I didn't prepare any slides about, but there's a whole other interesting kind of work on like recovery. So stroke recovery, for example. There's a really pretty effective method called melodic intonation therapy, which is basically about kind of getting people able to speak by scaffolding it onto song. And I think there's interesting reasons why those things, I mean, I actually believe in those things. I think there's interesting reasons why those work, but they're a little bit different than what I'm focusing on today. The problem with all of this is that it's almost all correlational, right? And you've probably heard, correlation doesn't imply causation. or maybe you haven't, but it's true, right? The idea is that, like, I could tell you that, oh, it turns out that ice cream consumption is really tightly linked to sunburns. And so, like, I think there's this sort of problem with, like, ice cream causing, like, all these skin problems. But of course, really what's going on is that ice cream consumption and sunburns both go up when the weather is nice. And so that relationship by itself isn't sort of useful, right? So by analogy, you could take these findings that I have over here, these various headlines, these are all from this year, and you could replace things like playing an instrument to something like coming from a stable home that can afford music lessons, right, is associated with better cognition. And nobody is surprised by that, right? I mean, that fits, like, a ton of work shows that's the case. So, I think these are, interesting findings, but it raises this question of, like, well, what does this mean, right? And in fact, there's some even crazier things. So, for example, there's a really big study that came out a few years ago from the Swedish twin cohort. So in Sweden, they have this really interesting group of about 11,000 twins that they have been tracking since birth. And they come in every year and they do lots of different things. So they have all this information on these twins over, like, the course of their life. And it turns out that if you take those twins and you find basically ones where there are dissociations between amount of practice, musical practice, then you find this really interesting pattern. So there's, like, various families where there's twins, and one of them got really into music and one of them got really into something else. And you can say, well, you should see pretty big differences there, right? But in fact, you don't. It turns out that once you control for the genetic variability, genetics predicts practice. And so practice predicts performance, but only because it's genetically determined by this study, which is wild. I think is also wrong, but or is overstated at least. But it suggests that it is not quite so straightforward, right? But this raises this interesting point, right? Because I sort of was talking about transfer, and I say, well, how would you know, or rather, what kind of effect might you expect? And maybe a good place to start is say, well, what's the near transfer kind of effect? Or rather, how much better do you get at music by music experience? And maybe that's going to set a kind of upper bound of what we might expect for you getting better at other things via music experience, maybe. Fortunately, there's nice work on this, and this is why I say that twin study is maybe a little oversold, because there is good evidence that musical instruction improves musical ability and musical practice too. So here's just one example. This is from a meta-analysis, and a meta-analysis, if you're not familiar, is a sort of technique where you basically gather a whole bunch of basically you try to gather all of the work that's been done on a topic, and you try to consolidate it by a bunch of different kinds of statistical procedures where you sort of bring them onto level playing fields, and you try to estimate the sort of consistency and the size of the effects that you're looking at. So this is a meta-analysis of singing instruction in kids. These are 5 to 11-year-olds across a bunch of different studies. 34 studies, it turns out, about over 5,000 kids. And they find that, in fact, there's good evidence that singing instruction improves singing ability with an effect size of 0.43. And you might be saying, yay, what? Like, what's that mean? What's 0.4, right? And it's a standardized effect size, which I can try to explain in a couple ways. I'm sorry, this is a little bit of an aside, but I think it's useful. We'll find out. So imagine that these distributions, imagine this x-axis here is singing ability. And I have two groups of kids. One group of kids took lessons in blue, the one here that's like kind of shifted to the right, and light blue, I guess. And the other group in dark blue did not take singing lessons. This is an effect size of 0.4. So you can see that those distributions are indeed shifted, significantly shifted in a statistical point, such that those who took singing instruction are better than those who didn't on average, but there's like a ton of overlap, right? Like there are plenty of kids who got singing instruction and are horrible singers. There are plenty of kids who had no instruction and are actually quite good. But that's okay, right? I mean, there's a lot of variability in the world. There's a lot of things that we think are at play here. So this is not surprising. This effect size is actually about as big as you usually get in sort of cognitive psych sort of studies, just because they're like complicated things. To give you a little bit of a sense, a little more calibration, the effect size of the difference in height by sex in the United States, so we know men tend to be taller than women, that effect size is about 1.7. So that's pretty standard, and that's a fairly big effect. Still lots of overlap, right? So here's our effect size of the effect of singing instruction on singing ability. So you might say, well, maybe this kind of thing is about as good as we might expect, in a big group study for the effects of sort of something like musical instruction on cognitive ability. I mean, maybe. There's a lot of, this is in kids and this thing and that thing. There has been, indeed, a meta-analysis on these sort of transfer effects to cognitive ability. And indeed, not that you can read this, I'm sorry for throwing just an enormous paper on the screen. But in fact, the biggest effect sizes they find are actually very close to that. They're about 0.35 in terms of intelligence. So kids who have music training across a whole bunch of studies tend to show better performance on intelligence tests, which is cool. However, they find another thing, because there's another thing you do in meta-analyses, which is you sort of evaluate the quality of the study in a lot of systematic ways. And they find a inverse relation between the size of the effects and the methodological quality of the study, right? Which means basically the better the study is, the smaller the effects get. And, that's obviously a little bit concerning from sort of a methodological standpoint. So what do we do with this, right? I mean, I think where my field is right now, everybody's kind of like, transfer just doesn't work. But I think, I think this is a little, I think it's a little premature to say that. I mean, learning music is complicated, right? So the really high quality studies here are basically randomized control trials where I take a group of people, whatever population I'm interested in, and I randomly assign them to musical training or some kind of control. The control is a very complicated thing here, because you think, well, what's the thing that has everything that musical training has except music? Right? Like it depends on what you think the kind of key point of music is, right? If I think, well, it's just about, pitch, let's say, then I have you do something like monotone music or like mono-pitched music, and that doesn't sound fun. I think that also differs in terms of like engagement and stuff like that. So control conditions are hard. Also, there's lots of sort of predispositional sorts of things, right? We think that a lot of musical ability is in fact genetic, at least genetically linked. And so it seems like people might have different predispositions that are going to make them better at certain kinds of music, but also maybe more engaged in it, and then thus better because it's rewarding and fun, right? If you happen to be sort of borderline tone deaf, you might be a great drummer, but you'll never know if I put you in a violin class. This is the best picture I could find, is Beethoven playing an electric guitar, because why not? Maybe he would be bad at it. I don't know. But there's a lot of decisions here, right? Like what kind of music, what kind of people, like, are you talking about kids? Are you talking about older adults? Are you talking about Parkinson's patients, right? There's work on all of these, but it's not clear that you would expect the same things. I should also note that I mentioned Lumosity a minute ago, like these sort of brain training things. And you may recall that Lumosity had to pay a $2 million fine for deceptive advertising because they claimed that their products would actually enhance cognition and protect against cognitive decline. And the data just aren't there, right? They might, but it's really not clear. But I think music is a little bit different, right? I mean, I think there's these selective things, and then I think there's a real tension here between the aspirations for experimental rigor that would give you this like strong randomized control study that would let you say something really convincingly, and the sort of ecological validity of like why people use music and what's good and rewarding about it, right? Like the reward and the social experience and stuff like that. Like, is that in these studies? It's not clear, right? And until we really know what kind of aspects of music we think are important here, I don't think we know how to do it in that kind of very kind of strong experimental way, right? So it's more than just acquiring mechanical or technical abilities, right? And so what I think, and this is sort of a promissory note, right? Like what is starting to happen that I think is really, really promising is that there is much more interest in these kind of maybe a little bit experimentally problematic issues, but or designs, which are these community-based music interventions. And there's a few of these that have been really good. I'm going to highlight a couple just because I have colleagues who are doing them. One is the Harmony Project and the Youth Orchestra of Los Angeles in California. This is this really great project where they're going into they got this huge grant to go into these like very disadvantaged neighborhoods in LA and just pick kids. And, there they can randomly assign people more or less because they can say, hey, you drew the orchestra thing. Would you like to be part of this youth orchestra? And people are usually like, sure, like that sounds cool. And then they go and they like work with like Dudamel at the LA Phil. Or they get put in like a pretty intensive soccer camp, and they have a couple of other control conditions. But basically all of these things, it turns out, seem to be pretty good for these kids. And nobody knows why, right? Is it because they're doing this thing instead of doing something else? Is it because these things have lots of protective benefits? We don't know, but they generate, I think, really good hypotheses, really good data that might help kind of inform what we're looking for. And clearly they're like good for the kids. Another one which I'll highlight is Singwell, which is a pretty new organization in Toronto. And this is about something a lot like what Bonnie sort of mentioned earlier, which is about understanding, informing, and inspiring choirs for individuals living with communication challenges. And so this actually grew out of some people who were studying music and Parkinson's, but ended up discovering that like, it turns out that Parkinson's patients who form choirs together quite like it. And they find it really beneficial, right? And exactly why is not completely clear, but they've started this whole project, which is about kind of expanding this and really giving the tools to lots of different groups to create community choirs for whatever their community might be. There's a group of there's a stuttering choir, there's a number of aphasia choirs out there, which are like surprisingly good. And, it's pretty neat. So anyway, I want to highlight this just because I think this is cool, basically. This is where I think we're actually going to learn something interesting, like not only because I think it can help, but I think this will maybe give us an opportunity to try to figure out like, what is it about music that is actually, that is actually sort of producing any of these sorts of benefits? Probably lots of things. But, what do I want to say based on what we know so far? Because I'm a hard-nosed experimental psychologist person. So is it good for cognition? I don't know, maybe. Is it good for brains? Sure, I don't know, maybe. Is it good for making music? Yeah, I think so. Is it good for enjoying music? I think definitely. And is it good for you? I think it very surely is. And so that's my take. And then I want to do one more quick, very self-serving thing, which is just this shameless plug. But I mentioned the MEG earlier, and Bonnie mentioned, deficits, language deficits after brain damage like aphasia. We're actually doing a project on language production in aphasia and sentence production. And part of this, we need, neurotypical participants so that we can kind of understand how sentence production works in a sort of neuroscientific way. It's pretty understudied. And so what this is we just have a little bit of pilot data so far, but we have a grant through the rest of the year, and we're really trying to recruit some people who are in the sort of 55 to 75 year range, roughly. And then if anybody is interested in that kind of thing, we would love to hear from you. We would put you in an MEG. We would make a fancy movie like this out of your and other people's brains, which, is mostly just for show, but actually it's pretty interesting. What this is showing you basically the sentence planning process in terms of magnetic activity across the scalp. So basically neural activity in the cortex. And this is over the process of planning to produce a sentence. So the more, when you know certain things, we can sort of look at what areas get active and in what order, so that we can look at how those the sort of timing and connectivity of those areas is different in people with achromatic aphasia, on the idea that that might help us start to understand how we can sort of help them. So anyway, if you're interested in that, there's my self-serving plug. You can email me. You can email aphasia.umd.edu.
As you touch it, you're rotating.
And that's that.
I would like to also offer, Dr. Slevc, that Hyattsville Aging in Place and Explorations on Aging, we have e-lists. We often, if there are studies going on at the university, are very happy to put that information out for you to get participants.
That would be great. I will pass some info on. Should I pass it on to you?
If you could, that would, to me, would be good. I can share it with Lisa at Hyattsville Aging in Place and UP. Sure.
That would be great.
Okay.
Thanks so much.
Great. Great.
Great.
Okay.
I'll stop there I'll stop there. I already stopped.
Okay, so we're looking for questions. Do people have any questions out there? And can you hear me? Yes? Okay, good.
Yeah, you can, if you don't feel like typing them, you could probably also just shout them out.
Raise your hand or
you should
whatever.
unmute first, probably, or else you'll have to shout really loud.
Carter, you had a comment that touch typing might be like what? Like learning music, but without the music?
The one of the controls where it was the same sort of activity. I mean, it's not taught the same way it was when I was in high school, but I remember Miss Aber, the teacher, pointing out one kid who was a pretty good piano player, and she was like much faster at picking everything up than the rest of us in the class.
That's pretty cool. Yeah, that's an interesting one. I would argue, I suppose, that like this argument comes from me having tried to submit a couple of grants on some music training interventions, and basically everybody always creaming my control conditions. But I would argue that like one problem is that touch typing is not like inherently enjoyable. Now it might be, right? It might be that music training at the beginning isn't either, and being able to type fast is like kind of rewarding because you can like, you know, do whatever. So it's a good idea. We proposed learning sleight of hand, which I thought would be like have this sort of interesting sort of motoric thing, but it was all kind of spatial. So I was going to do that and juggling, but
That's cool.
yeah, I wish you were my grant reviewer because I think that was cool. But,
Helen Knowles, which you could say, Helen, you said, wait, I found listening to classical music really lowers my blood pressure and calms me down.
yeah, I think that's, I mean, there's a whole other kind of interesting, well, I'll say two things. One is I think that fits really well with the idea that like a lot of the sort of short-term effects of musical listening are kind of mood and arousal based. So it might be the case. I mean, I sort of said that, oh, if you like Metallica, Metallica will work just as well. But that's probably actually not true. Like, I think that it will work. It will work. But there do seem to be some kinds of like acoustic characteristics that are more calming that some sort of music uses and others that are less, right? And that there's an interesting kind of subfield trying to find universals in music. And so far they have found zero, but they have found what they call statistical universals. There's a guy, Pat Savage, who I've worked with a little bit, who does this stuff. And basically there are things that are true like 95% of the time. You can always find an exception, right? So they're not like real universals, but they're like basically universals. And some of those have to do with this, that like, you know, like fast tempos and certain kinds of timbres like are more like arousing and some are more calming and stuff like that. So yeah, I mean, I think that's a real thing. And I think it probably interacts with preference and experience too. But it's a good point. Oh, we have a musician who failed touch typing.
Yes.
Oh. Well, the question is, what kind of musician are you? Maybe you have to be, maybe it only works for like pianists or people who like use GarageBand on their computer.
I'm a singer.
Oh, well, there you go. You maybe you're good. You're better at, are you better at dictating to your phone?
Nope.
Yeah.
Don't do much of that.
Let's see. Has music been tried to wake people from coma? Yeah. Oh, I'm sorry. That's not a theoretical question. I can't tell you if it's been tried, probably. There's interesting work on post-coma patients showing evidence that they can represent some music that they have heard during their coma. And it's not all of them, certainly. It's not like a robust effect, but there are cases where it seems like you can show basically indices of familiarity both during the coma and after. So there's certain kinds of like neurophysiological responses that you can record from the scalp that indicate kind of surprise, right? And that sort of goes down to some extent with exposure. I mean, an interesting thing with music is that there are things that are surprising even when you know the piece really, really well. Like they're surprising kind of in light of all music you know, not that sort of particular piece. But anyway, there's some evidence that you can show that in some cases that people they seem to show some kind of, I don't know if you want to call it recognition or not, but some sort of like some evidence that they've processed that and learned something about it. So it's, you know, my own sense is that like one of the really nice things with music interventions compared with a lot of kinds of interventions is it's very hard to imagine that it will hurt. I mean, at like maybe very high volumes or something it might, but so I would say like, why not? Like if you know, there's definitely good evidence for like Alzheimer's, for example. In Parkinson's, there's a lot of evidence that patients can often move better with sort of very rhythmic music. Like, I don't know for sure about coma though. Sorry, that was sort of a long answer for me to say I don't know, but musical and language ability, yeah, that actually is a lot closer to what I actually study myself. And yes, there are pretty robust correlations between music and linguistic ability, both in terms of first language learning in kids and also in terms of predicting how good people are at picking up second language as an adult, which, is sort of a notoriously difficult thing. So being able to speak with a native-like accent and stuff like that. There's, a lot of it is still correlational, but not all of it. And I actually have a sort of take on this that I'm not sure most of my colleagues agree with, but since they're not here, I can tell you, which is that I think that music and language are not actually different things. I think developmentally, there is organized sound that people care about, and infants tune into that. And over time, they have to learn that some of it has been sort of formalized and sort of codified almost in very particular ways where you don't get to play with it very much, right? I can't just decide to say this word like totally different because I feel like it. But then you can do the same stuff, but you can play with it and have fun, and that's music. But I think they start the same. And so I think a lot of those relationships actually just reflect the fact that, it's basically the same machinery doing both of them. I don't know. That's my take. Of course, every time you say this, then you find these really interesting dissociations where you can find people who have specific forms of amusia, which is either congenital or acquired after brain damage, music deficits in the sort of existence of completely spared, apparently, language processing, and vice versa. So it's definitely the case that many aphasic patients have really no musical kind of deficits, except that those that might be sort of motoric because of stroke kind of motor reasons. So I think they sort of specialize over time. Yeah, Carter.
Yeah, just you're saying that, and I'm just wondering if there's any relationship that's been noted between the types of music scales or the different sorts of tonalities in different musics versus languages. Like a lot of Asian languages have tonal characteristics that we don't have in a lot of Western languages, and there definitely are differences in traditional musics in both sides.
Yeah, that's a great question. A sort of related thing that came up a few years ago is there was a bunch of us at a conference making a big deal about music and second language learning and how music is sort of importantly tied. And there was a bunch of the work there was on tone language learning, which kind of made sense because you're like, oh, it's got like pitches in it. It's kind of more music-y. Not that English or something doesn't have pitch, but it's not contrastive, right? Like you can do kind of whatever you want with it. And maybe you sound a little funny prosodically, but somebody came up and was like, hey, listen, I study a music people, and there's a whole bunch of them in China. And they speak Chinese just fine, right? So what do you do with that? And it turns out the answer is that tone languages are kind of interesting because the tones are almost always pretty far apart. And one argument is that's because language is sort of required to be understandable by most of the population. And so if you have some people who have trouble resolving sort of small pitch differences, then language better use big pitch differences. That's the argument. Or a lot of times they use contours, so rising and falling, which might be a little different. But it's a really interesting question. There's also this whole kind of interesting body of work on talking drums. And there's a language called Sobogomera in Spain in the Canary Islands, which is a whistled language that sort of developed among sheep herders who are, very far away. And it basically, people just whistle the prosody of what they want to say. But it's become kind of structured enough that it's essentially a communication system, a language system. And it is pretty effective. There's not tons of work on this because, most of us are sitting around at places like Maryland in a psych department with kind of easy access to 20-year-old undergraduates. And most of them don't speak Sobogomera whistled languages. But I think those are cool questions. Let's see. I feel like I missed some.
Yeah, there are.
Harmonicas. Yeah, you got me. That's pretty cool. Bonnie, is your husband I think I see you there. Hello. Good at picking up kind of accents or imitating people or anything like that? You imitate voices? No? Interesting. I was wondering if it was sort of you can think of a lot of the sort of harmonica-like instruments, jaw harps and stuff as being very they use a lot of the same tools as speech articulation, right? So
if he's being silly and mimicking, yes.
Yeah.
But he's not, I would say, a natural second language learner.
No.
That didn't work for him.
But it might be I wonder if you could imitate the sounds pretty well, even if you had trouble, learning the.
Well, the other is that if he's ever heard a song and it's in his head, he can play it. he can just go play it.
That's cool.
There's no effort at all.
That's cool. And I think music memory is something that I find really fascinating because people have this, like, people sometimes are like, oh, music memory is not that different. Than, like, I can remember, like, what
But I
someone
want to know
was
what the
talking about.
translation from this memory
But
to the muscle memory.
the thing that's interesting about music memory is that the timing matters so much. Like, the actual order of exact events is what makes a tune a tune. But if you ask people to remember what they were talking about, they'll just make up a version of it, which will like be kind of mostly the same. But like if you asked me to repeat a song and I just repeated something that was kind of like it, that had the same general idea, you'd be like, that's not the same, right? That's a different song. So it's like a sense it's more veridical because you don't abstract away to some kind of message. So that's cool. I will share, because I see that she's not online anymore, that my partner has actually the opposite problem, which is she's very into music. She knows lots of songs, but she cannot for the life of her remember a melody or the lyrics of something. It's really the lyrics especially, actually. But it's like, she can't remember stories either. Like, she remembers the context, but the actual order, just nothing. I don't know. That's interesting.
But it takes all kinds to make a village.
That's right. And I mean, I think, music and language are interesting because they are of the village, right? I mean, they're like for the community. And so they vary a lot, but also they have to sort of be flexible enough to accommodate all of these different abilities that people have. And I think when you start talking about transfer effects, that's part of where we get in trouble, because you say, well, what we need to do is teach, whatever, classical guitar, that's the thing, right? And it's like, well, that's the thing for some people, right? Donkeys and guitar playing. I have a bunch of slides which I almost put in here on music and non-humans, because it's a really interesting question, because most theories of sort of what music is for, evolutionarily speaking, do not explain why humans are so into music and non-humans do not appear to care very much. There's work trying to get, one thing that's kind of interesting is that it turns out that a lot of animals have absolute pitch, and most animals do not have relative pitch. So if I try to teach a pigeon or something to respond when it hears a particular melody or sequence of tones or something, it can actually do that just fine. But if I transpose it, it's like not the same, right? And so things like you might think that you have to sort of have this underlying representation of octave equivalence and sort of pitch height and pitch chroma to be able to scaffold any kind of tune onto. And if you don't have that, then they're just sounds. As a toilet flush, if I transpose toilet flush to bowling ball crash, what does that do? And you're like, those just are different things. That doesn't make any sense.
Yeah.
I don't know. I sometimes think about it like colors, right? We perceive colors categorically. Like a blue is a blue, and it's not like I can shift the color space and when blues are green, and then that means pinks or something else. Anyway, sorry, that was a bit of an aside. But donkeys, yeah, I do think there's evidence of there's some interesting evidence of non-human animals showing components of musical kind of abilities, and there's definitely evidence of animals responding to music. There's some question of what exactly they're responding to, and I don't know. There's a kind of cool group that has this elephant orchestra in Thailand, which is it's an elephant rescue, and they basically just made these enormous instruments for the elephants to play, and the elephants kind of like to do it. There's an album you can get from, I think, Smithsonian Folkways on it. It's kind of interesting. Bird communication is interesting too. I think there's decent reason to think that bird song is probably not song. Like we interpret it as song. It's not clear that birds interpret it as song. I think bird song is more like speech for most species. But then I also said I thought speech was the same as song. So, you can have it however you like. Let's see. Newell's point about vibrations is a really interesting one. One of the problems of finding other activity is that music isn't just the sound, right? It's also the sort of tactile vibrations kind of component. And in fact, there's an interesting body of work in music in the deaf. So there's lots of deaf people don't particularly care for music, but actually a lot of deaf people do. In fact, the Grateful Dead at one point on tours used to have a section for what they called the deaf heads. They had a big crowd of basically Grateful Dead fans who were deaf, and they would stand really close to the speakers. They would reserve this section for them, and they would have streamers and stuff taped to the speakers too, so that you could see them move with the sound.
That's cool.
There's even deaf musicians who perform, music in sign language essentially, but that, is different than sort of sign as a communicative thing. I actually think that stuff is super, super interesting. But I might have just told you everything I know about it. Yeah, let's see. Apraxia, music and apraxia. That's a good question. I actually don't know if people use music and apraxia. I wouldn't be surprised. I mean, there's a sort of funny disconnect between the kind of cognitive neuroscience of music and music therapy. And I think the disconnect is not dissimilar from kind of how I ended my slides, which is like music therapy is very interested in finding the appropriate way to engage with people on an individual basis. And cog neuro research is very interested in controlled conditions, right? And those don't play well together. And so like, I think from my perspective, I don't know much of the sort of music therapy end of things because it doesn't intersect with the work that I do in the sort of like journals I publish in and stuff like that, which I think is too bad. There's like some move to change that a little bit, but it's been hard. And I think it's hard because, what happens is somebody like me waltzes in and is like, what we need is you music therapists to like, randomly assign people to therapy and no therapy and this thing and that thing. And they're all like, what we need is for you to go away. And like, that takes care of that. Right. And they're not wrong. I mean, like, yeah, I don't know. But I think, so I'm sorry, that is another long way for me to say that I don't know. I know melodic intonation therapy in part because there's been more controlled research on it. And in part because, and I will say melodic intonation therapy is used with apraxia in the sense that it's typically used for Broca's aphasia, who often also suffer from apraxia of speech. Apraxia, do you all know, is basically about motor production of speech in particular. Yeah, let's see.
Flan also asked about synesthesia.
Oh yeah, synesthesia. Oh, you found the Thai Elephant Orchestra. Oh, cool. Yeah, synesthesia. Boy, I don't know. I have a lot of thoughts about synesthesia.
What is it? What is it? What is it?
Doesn't know what is it? Right? It's I believe it's Latin for cross senses or something like that. And basically, synesthesia refers to an experience where information in one modality is sort of associated with information in another modality. And I'll give you better examples. Like one kind that gets studied a lot is what's called grapheme color synesthesia, just because it's one of the more common kinds. So these are people who perceive letters as having colors. Not necessarily as being colors, but like as having them. So, I say A's are just red, and that's just like the way they are. It's like part of their inherent nature. And that's true even if you give me an A in green ink, right? And there's like been some interesting work on it that suggests it's a real thing. The sort of neuroscience story broadly is that, the trajectory of brain development is that you have, like, it's not what you might think initially, which is you have this very sparse brain and it grows and it grows and grows. What happens is you have a brain with just connections like everywhere, and they prune and prune and prune and prune, right? And one argument is that, like, maybe what this is the brain having the ability to specialize fairly early in life. So you basically, everything's connected to everything, and then you sort of see which connections turn out to be useful and you ditch the rest, which is easier maybe than growing new ones or something because you don't know what they do. And in synesthesia, the idea is they didn't prune all the way. And so it turns out that color, the bit of cortex that cares a lot about color, is right next to the bit that cares a lot about letters, about graphemes. And that might be why grapheme color synesthesia is pretty common. It just so happens, some people have some cross connections. But
isn't there, I do know someone who worked in a bank, and she became the expert at detecting counterfeit because when she saw color, she could hear sound. She also painted by sound. So she did reproductions of masters through sound.
Interesting. There's other cases of this too. Messiaen's a French composer. I might be saying his name wrong. Messiaen, but he was known for doing things like composing symphonies in yellow and like yelling at the orchestra for not playing blue enough.
That's hard.
there's some story which I wish I could find for you, but some particular like account of somebody like complaining about how hard it was to play in his orchestra because he would just have these like ridiculous things that he would say. but probably synesthetic. It does seem to be overrepresented in artistic fields, perhaps unsurprisingly. It isn't just visual. So as you mentioned, Bonnie mentioned, there's sound. You can also have tactile synesthesia. So people who have feelings associated with either sounds or tastes associated with sounds or graphemes or whatever. I don't know. I mean, it's pretty cool, as I guess is what my thought is. I think, in the last 20 years or so, I would say that there's been enough, there's been work that has been not just descriptive on it, which has, I think, convinced people that it's a real thing. Some of it's the kind of stuff like Bonnie was just suggesting, where you can show that people have certain kinds of like advantages that would only make sense if their, phenomenological experiences really exist, like being able to detect particular letters off in the periphery because you're like, oh, well, it popped out to me because it was green. And I'm like, well, it wasn't green to anybody else. Yeah, I don't know. It's cool.
Flawn, how do you know about it? Flawn, are you still here?
I don't have a lot of knowledge about it, but have run into situations of people associating certain types of music with certain colors and things of that sort.
There's an interesting question related to that, actually, which is like whether there's some consistency. And I think there's some consistency in the grapheme color. I don't know about music, though. But you might think there would be. But I don't know. There's a story, too, that's synesthetic. Some of the more common synesthetic things might underlie the metaphorical use of language that we use, right? So when you say things are, this thing is, if you refer to sad things as blue, right? Like maybe there's some reason for that. And maybe that's mediated by sad music being associated with a particular color more often than chance or something. But, that's obviously just total irresponsible speculation. Which is why we're here, I suppose. Yeah.
There are other questions. I think there was one comment about shepherds and communicating about using tones to tell people about conditions in the mountains.
Yeah, let me send you the one I was thinking of is there's probably more than one, but here's one, the one I mentioned on Sobel Gomera and the Canary Islands. That's pretty cool.
Yeah. And for everybody, Carter did put in the chat the Thai Elephant Orchestra, if you want to, the YouTube connection, if you want to take a look at that.
Yeah. Yeah, and some stuff on birdsong that somebody pasted in here too, which is pretty cool.
Right.
I actually don't know this paper, so this is cool. There's a lab here at Maryland where I've been, over the last 10 years, we've been developing a collaboration that has never gone anywhere, but trying to look at basically sort of language and music comparisons in birdsong, because, you can use birds like budgies are pretty cool for this because they'll learn all sorts of stuff. So you can teach them things with whatever characteristics you want them to have, and then look at kind of how they use that and how they transfer that to other budgies and stuff.
Mm-hmm.
But we never went anywhere with it yet.
So here's a question. How does music elicit emotions? Is it by association, or is there something more fundamental and universal, like major is happy and minor is sad?
Yeah, that's a great question. People like to say that music is the universal language, and this is one of the things that people like to point to, right? Is, it has these sort of characteristic emotional things. And then people will say, maybe this tells you about language-music relationships. There was some work a few years ago that suggested that sad sad speech actually has a surprising amount of minor thirds, descending minor thirds in it. And then you'd be like, does this mean that music has sort of piggybacked on what makes speech sound sad that we know, or conversely, is it that when people want to sound sad, they're kind of singing in a way? I will say we tried to replicate and extend that, and we completely failed. So may not be true, but I think these ideas are really interesting. I mean, again, the work on musical universals suggests not universally. So major minor is a good example of, you can find plenty of examples even in Western music of sad major, happy minor. Hava Nagila is a good example of a kind of really happy minor song. I mean, that's a super minor song, and it is get dancing, guys. But I think it contributes, right? And it's really a good question how much of that is kind of cultural learning and associations, or kind of timbral characteristics. Like it's a hard question because like also, sad speech, for example, tends to be kind of a little bit monotone, a little flat, a little quiet, and a lot of those things. I mean, sort of quietness is usually associated with calm or sad. There's some work looking at people characterizing music from different cultures and trying to kind of guess what it is. I mean, Carter, you're right though. Like these things where you shift the key of a song could completely change it. And I do recommend looking at those on YouTube. They're actually pretty wild. But
do you have any of those connections, Carter? Could you throw them in the chat? And maybe when we send out the after notice to everybody, we could put some of the connections in the email. Does that make sense?
yeah, I mean, I think some of these are like I'm thinking of they tend to be things like Every Breath You Take or Losing My Religion or something, where they're like these kind of sad, pensive songs, and then you make them major and they like sound silly. And it's like, what's going on?
Right.
Yeah, they're pretty cool. Let's see. Did they look at electrical brain signals? Can you tell me what you're referring to, Gene? I'm sorry, I don't think there's too many threads in here.
I was assuming there'd be an EKG signal or something like that. I'm not exactly sure what, but one hears of studies of the parts of the brain that create certain signals. Or
Yeah. We do. There's a couple different things. So I mentioned some MEG stuff, which isn't electrical, but it's basically correlated with electrical because electrical fields generate a parallel magnetic field. So those are related. We also do EEG. We're doing some stuff now, which is measuring electrical potentials on the scalp, which is basically EKG, but on your head. And then there's been some work, which is actually really interesting, looking at implanted electrodes in patients with intractable epilepsy. So there was some stuff a little while ago. You may have even seen this video floating around. I think it was from Eddie Cheng's lab in San Francisco, where they had I think it was a professional violinist who was going to have a temporal lobe resection to prevent seizures. And so one of the things that this is a procedure that started in the 50s and people still do it, is you just cut out a chunk of the scalp around where you're going to resect some cortex, and then you just stimulate it while people do things. And you see like, well, which part, if I zap it, like really messes you up? And let's try not to take that part out, right? And usually they do it for speech because it's like, well, you don't want to like lose the ability to speak if you can avoid it. So we'll try to keep the eloquent brain areas, as they call them. But for this particular person who was a musician, it was very important for them to be able to play music. And so they actually had this person like with basically a hole cut out of their scalp, stimulating different parts of their brain and like playing the violin. And it's really wild because you can find at some point where they're like, bloop, 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 right? And it's like, oh, I can't play anymore, right? And you're like, okay, better keep that part. It's a cool technology. You can do it recordings too, because what they often will do is put in a bank of electrodes and then kind of cover you back up there so that they can measure over a long period of time and try to detect exactly where the seizures are coming from and stuff like that. So there's very cool work that comes from that. It's a little hard to know how to generalize it because they're sort of by definition abnormal brains that are creating massive seizures and having a lot of reorganization for that reason. But it's still, I think, very cool. There's one other thing I'll mention that's kind of neat is there's a thing you can record actually just from the top of your scalp, which is called the frequency following response, which is actually a brainstem response. So very early in auditory processing. And what is kind of interesting about it, it's not that early. I mean, it's all the way past, your ears and auditory cortex and, and cochlea and all that stuff. And what's kind of interesting about it is you can take the signal that you record from the brainstem and you can just run it through like a synthesizer and play it back. Because it's just it looks like an auditory signal because it's just an oscillatory, signal. And it sounds like the thing you heard. Oh. So if you play, but what's interesting is the extent to which it does relates to things like musicianship and a few other individual differences. So some people have very veridical brainstem activity that really maps very tightly onto the sound that they heard. where it sounds kind of, I mean, it sounds kind of low pass filtered. It sounds like a really lousy recording of what you heard. And some people have much less veridical, like it's much noisier. And that seems to track onto a bunch of different things. So it seems to be kind of an auditory processing and organization. Excuse me.
Wait.
I don't know if
we
that
had
gets at all to
something
what
here.
you were asking about, but
Someone wanted to know if you play music, if you're a musician, and what genre.
I am unfortunately, I don't know if my parents are on here. They're going to call me out. Not really, no. My mom actually was a music teacher and an opera singer and all sorts of things, and music has been like a huge part of my life. But I've kind of been like a serial give-upper on things. So I've played some things for a while and then got into other things, and played those for a while and got into other things. And so I won't commit to playing anything now. I did sing for a while. But yeah, genre, I don't know. I like lots of things. I think, I mean, these days my genre is primarily music for 2 and 4 year olds. And so I sing a lot, actually. But it's the same few songs over and over again. So not really my preferred genre, but I'll get there eventually.
Okay.
Let's see. That sounds cool. Oh, and the playlist of these songs, great. Fine, Carter. Look at that. It's all of them. Amazing.
Betty Giles, I hope that's the way she said it. She pronounces her name, says she's read that music was very important in ancient religions. As in many current, she can still remember as a young person feeling a lot of emotion during fundamentalist church meetings, and later realized she could get the same result by singing with non-religious music with friends, especially with harmonies.
That's cool. There's a story out there which I really like, that a few people have been kind of pushing recently, which is that what music might have gotten us, evolutionarily speaking, is the ability to be a little more independent. And so the idea here is that kids are helpless, right? Human babies are like little blobs that can't do anything on their own. And so normally you would just sort of they would stay attached to you, and they will like freak out if not, right? And what music maybe lets you do is stay attached to them even when you're not, right? So the idea is you can put them down, you can sing, and it has a sort of social connection that allows you to kind of move around without them and allows them to kind of figure out other people who are okay and stuff like that. And this sort of distant connection might have predated language, right? But that, this sort of social connection. There's a term for this, which I am unfortunately not coming up with at the top of my head, but basically the sort of social connection, especially for young kids, might have been really, really critical. And then, if that's such an important part of your sort of social worlds when you're little, of course, it continues to be so.
I'm noting, we have a couple of more comments about choirs and unchoirs. I'm noting that we are at about 3:24, of which, we usually go to 3:30. We can go longer, but we want to be respectful of your time.
Thank you. It's really respectful of my partner's time, who is home with the kids. So
yes, right. Carter,
I will actually note this, Bonnie, thank you for reminding me about the unchoir. Yeah, I thought the unchoir was great. I hope it comes back.
I do too. Yeah. It's for all those people who are not terribly good singers but love singing. It was really fun.
Yeah. I will tell you, since you asked about, or somebody asked about my musical sort of abilities or whatever earlier, I go to these music cognition conferences, and the first couple times I was always very stressed out because sometimes people will have like jam sessions or something, and they're like there's some pretty serious musicians in that crowd. But at some point I hooked up with a lot of people who are music cognition, music perception researchers who just love to karaoke. And like, karaoke is great. I mean, there's no bad karaoke except for too earnest, good karaoke. So maybe that's my thing, is like karaoke.
That's cool.
But unchoir, I think, has that social component, which is really nice.
Well, then, if we're okay, we'd like to say again, a very big thank you for a wonderful
thank you.
presentation, interaction, conversation.
Thank you, everybody. And we will be getting out information about our next series starting up in January.